Hey guys, welcome back to the Pepcoding. So in this video, we are going to discuss our next question, that is find rotation count. So in this question, we have an sorted rotated array and of size n, and it is rotated by k times, and we need to tell that what is the value of the k. Okay, so this is the array, and if it is not in, or if it is not rotated, then it looks like 4 5 6 7 8. It look like that. The these five values from the last are shifted from right to left. Okay, so this looks like 4 5 6 7 8 and 0 1 2 3. Okay, 0 1 2 3. Now this is the same question as the previous one. In the previous question, that is the find the minimum element in the rotated sorted array. So this is the same question as the previous. So in that question, we are dividing the array into two parts. First this, second this. This is the part 2. Part 2's first element is the minimum element in the array, and part one's last element is the maximum element in this array. So at this point the ascending order are break. 8 is greater than its next element, so ascending order are break here, not the sorted order. Now if we have the minimum elements index, then we have the rotated count, how much times the array was rotated. Okay, so 1 2 3 4 and 5 elements are come before 0, so it is rotated by these times, 5 times. It is rotated by 5 times. So I recommend you to pause the video here and do the code by yourself. So let's start with the solution. Now let's try with this. If we want to find the case value, then we are using the binary search here. So if our midpoint is this, so we can say that if our array of mid is greater than array of mid plus 1, if this condition is true, then we are returning mid plus 1. Why? Because if this element is greater than this, it is in sorted order, sorted, but it is rotated. Okay, if this element is greater than this, then we know that it is the smallest element in this, because it is in sorted order and rotated order. Okay, so we are returning mid plus 1, so we are returning 5 here. If our mid is this, our midpoint is this, then we are returning this point, and we are checking that if our array of mid is less than array of mid minus 1. If it is, this condition is true, then we are returning our mid. Okay, we are returning our mid here. So this is our array of mid, and it is less than of array of mid minus 1. So we are at our correct position. So let's try to do some code here. So for the binary search, we need two pointers, one at low and one high at array dot length minus 1, because we want add this point as a first point. So we need a while loop, that is low is less than equals to high. If this condition true, then again go into that loop. Okay, now for binary search, we need a midpoint, that is low plus high divided by 2. Now first condition is this. If this condition true, then we are returning mid plus 1. If our mid of array of mid is greater than array of mid plus 1, array of mid is greater than array of mid plus 1, then we are returning our mid plus 1. So let's write the code for it. If our array of mid is greater than array of mid plus 1, then we are returning the mid plus 1, because the next element is the smallest element. Else if, so let's write this into next line. Next point, if our mid element is this, if our mid index is this, then we need to check that if 8 is greater than, that means if our array of mid minus 1 is greater than us, if array of mid is less than array of mid minus 1. If it is, this condition is true, then we are returning the midpoint from here. Why midpoint? Because we are now at the minimum elements index. It is that's why, that's all we want. Now else if now we need to check that this is low, this is high. Okay, these two condition. If our mid is this, now our mid is this, then we need to check that where is the low pointer and high pointer will be go. So if array of low is less than equals to array of mid, then update the low as mid plus 1. Okay, and the last condition will be else if the array of mid, if the array of mid is less than equals to array of high, then if this condition true, then update the high as mid minus 1. So this is our code, and one test case that we want to check here. Just erase this first. One test case is if 0 1 2 3 4 5 6 and 7, if the given array is not rotated, only sorted order, not rotated order, then we need to check that this is a minimum element and we need to return this element's index. Okay, so we are checking that if array of low is less than array of high, so array of high is 7 here. Now we are checking that 0 is less than 7. Yes, it is true, then return the 0. Why 0? Because this is not a rotated array, this is sorted array, not rotated, sorted. Okay, so we are returning the first point. If this condition apply here, is 4 is less than 2, no, this condition is not true, then it will not going into that loop. Yeah, this condition, so we need to write that condition as well. So write this condition here. If array of low is less than equals to array of high, if this condition is true, then we need to return 0 from here. Okay, so this is the code. Let's try to run this code. So let's try to submit it. So the code was accepted. Let's try to dry run of this code. Okay, now so this is our code. Now we have low and high point, low at 0 and high at 7. Now we are checking that is array of low is less than equals to array of high. No, this condition is not true, then we are it now in next condition, that is while loop. So low is less than high until and unless low is less than equals to high. We are finding the midpoint. Now we are at our midpoint. So is array of mid is greater than array of mid plus 1? Is 7 is greater than 8? No. So we cannot go into this condition. Now this condition, array of mid is less than array of mid minus 1. Is 7 is less than 6? No. So we cannot go into that condition as well. Now array of low, that is 4, is less than equals to array of 7, that is 7. Array of mid means 4 is less than equals to 7. Yes, this condition will be true, then we need to update our low here. Now our low is here. Again we are finding the mid, and the midpoint is this. Now we are checking is array of mid is greater than mid plus 1. Is 0 is greater than 1? No, it is not 1. Then we don't go on to that condition. And now checking if this condition, array of mid is less than array of mid minus 1. Yeah, is 0 is less than 8? Yes, it is 8 less than, then we are returning our midpoint here. So this is the dry run of this code. So I hope you understand the question and the solution of this question. Thank you for watching.